Teacher knowledge and behavior is the component of the model that focuses on teachers' knowledge of students and content and on their expertise in classroom management and pedagogy. Teacher knowledge is the element of teacher knowledge and behavior that encompasses knowledge of student characteristics and teachers' in-depth content knowledge and the blending of these to enhance learning. More information on this can be found in the Technology as Facilitator of Quality Education model. An elementary mathematics class is studying graphs and graphing. The teacher demonstrates knowledge of student characteristics by addressing her students' visual spatial intelligence. The teacher reviews previously learned graphing concepts using an overhead projector. She discusses the different types of graphs the students have studied, drawing an example of each on a transparency. This helps the students form a mental picture of how different kinds of graphs convey different kinds of information.
Boys and girls, today we're going to talk about graphing. And you remember that we've done some graphing before. And we have different kinds of graphs, and the different kinds of graphs are used for different things. A graph is some kind of information that we use, and then we try to organize it so that we can understand how we're going to use that information. It usually represents things or shows relationships between things. And that's what a graph is. Does anybody remember the kind that had the lines and the dots and the name of that particular kind of graph? Mallory? That was a line graph. And when we have a line graph, the line graph presents information usually that happens over a period of time. How many of you at home have like a chart of your height as you grew older? You could graph that. At your age, when you were 2, you could put a little dot on your graph, and then hopefully you grew just a little bit when you were 3, and you have another dot. And then now you're probably up here. I don't know how far you're going to go on that graph, but that would show something that happened over a period of time. Okay? So we have a line graph.
The teacher displays knowledge of student characteristics by giving her students the opportunity to use their intrapersonal intelligence. The students work independently to gather information about the number of the different colors of candy in a bag of M&Ms. The students conduct their own investigations individually, recording their information in a table and representing it as a graph.
Okay, I'm looking at the time, and that means that I said I'd give you 5 minutes.
The students use their bodily kinesthetic intelligence when they count and sort their M&Ms. Manipulating concrete objects helps some students learn and remember concepts. The teacher shows knowledge of student characteristics by designing an activity that allows students to interact with their physical environment.
Okay, I'm looking at the time, and that means that I said I'd give you 5 minutes.
The teacher further displays knowledge of student characteristics by addressing her students' logical mathematical intelligence. The students work with a partner. Based on the number of M&Ms of each color they found in their own bags, the students guess how many M&Ms of each color would be in 2 bags. The students make their predictions, then combine their data with their partners to test their predictions.
Write it on the paper, okay? So you're going to say, okay, together I think, because I have 10, then together we're probably going to have 25. So you put 25 right here. That's your guess. And then you guess for the blue, and you guess for the brown, and guess the green, and the orange, and the yellow. But he can't look. Okay? So 15. Get a number there. Then put 15 if that's what you think.
15 brown and 19 orange.
Well, you don't know how many he has. You just guess. Say 30 then. Don't look. Say 30.
8, 3, 11,
The teacher has the students use their data to make a general statement about the contents of a bag of M&Ms.
So let's see. We'll just use yours because hers is exactly the same, right? So look at the number of red that were there. There were 23. Now, do you think, and look at the number of blue that were there. Very few. Number of green, not as many. Number of orange. Do you think that in most packs they will have more red and brown like yours? Or would they have more blue and orange or what? What do you think?
Red and brown.
Okay, then maybe that might be your sentence, that most of the time you'll find more.
Oh, okay.
Oh, okay. Do you agree with that, Stephanie?
Yes.
Yes? Are you sure? You don't want to write anything different?
I'm sure I want to agree with my friends.
Okay, but you don't have to, you know.
At the end of the lesson, the students work together on computers to create a spreadsheet and a graph of their data. The teacher demonstrates knowledge of student characteristics by encouraging the students to think critically when they interpret their data. She gives the students some examples of generalizations. The students use their logical mathematical intelligence to find flaws in the teacher's thinking and to address possible flaws in their own interpretations.
There will be more round M&Ms because it is more likely to look like chocolate.
Okay. Whoa, was that what you said too?
Yes.
Well, that's okay. See how far away you are and you think alike. And that's very good because, yes, maybe they look more like chocolate and people like chocolate.
I think all cats is the same in the whole world.
Okay, so he and his partner think that all of the packs of M&M are the same in the whole world. Same in what way? And that they will have different numbers, is that what you're saying?
I don't think some packs are the same.
Okay. You're saying that no matter which pack you pick up, whether you are in Afghanistan or if you're in Los Angeles, that you could not have the same number as another pack somewhere else. You're saying it's all going to change all over the world, right? Okay, good. Anyone else have any ideas or would like to share?